My name is Stacy Thibodeau, and I will be your host and presenter tonight. I have been in the science classroom for over 20 years. I currently teach at Southside High School in Youngsville, Louisiana, where I teach all levels of Chemistry 1 and Chemistry 2. I also teach a robotics class using lots of the projects that you'll see tonight and using TI technology. I also use TI technology to assist my teaching, data collection, and modeling math concepts, linking them to science content. I am actually presenting this webinar from the CAST conference in Dallas, Texas. So very honored to have another presenter here tonight, Ms. Jessica Cahoot. Jessica earned a Bachelor of Science in General Biology from the College of Computer, Mathematical, and Natural Sciences at the University of Maryland, College Park, and Masters of Art in Teaching and Secondary Education from Goucher College. She was a biology teacher at Reservoir High School for the last 17 years, but recently transitioned to informal education. Currently, Jessica is the Youth Climate Institute Manager at Howard County Conservancy. In or out of the classroom, Jessica believes that teaching students STEM skills along with collective action are the way to improve the future for all. Thanks for being here tonight, Jess.
No problem. I wouldn't be anywhere else. It's great to see you.
We are expecting a large crowd tonight, so your audio is muted. Feel free to send questions to all panelists using the Q&A window that Jessica is going to help moderate tonight. We'll also send general messages in the chat window. This session is being recorded, and as a reminder, we will provide a link to this event certificate of attendance at the conclusion of the webinar. Once the webinar is available, if you'd like to follow along with your handheld or software, and we hope you will, we recommend doing this with the recording so you can download the activities and pause and rewind the recording as necessary. We don't expect you will have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, Audio Broadcast, and then click Join. All right, Jess, you want to go over the agenda for tonight?
Sure thing. So what we're going to be working on today is introducing you to some coding resources you could do with your own students in your classroom based on our own experiences with working with students. We're going to be working with Python. So the programming language we are going to be introducing will be Python, and show you some activities that we've done in Python, go over any questions you have. So really try to be specific to your needs if you have any. So feel free to use that chat to ask any questions as we're going along. And then one of you will get some free stuff to take home, which is very exciting. So there'll be a drawing at the end. So make sure you stay until then, and you might be the winner.
Absolutely. Thanks, Jess. Also tonight, we hope that at the end of the webinar, if you're joining us live or after you watch on demand, you will be able to locate and identify STEM project resources. Jess and I will share a few different websites and resources for you if you're getting started, or if you want to borrow some technology. We also hope by the end of the night tonight you can code some simple programs in Python. We're going to try to do some live coding, showing you the TI Innovator Hub and the new and latest and greatest microbit. And we hope that you can connect these programming activities to classroom activities that you currently do, and also to future STEM projects. Like we both mentioned, please use the chat window to send messages. If you don't see it, open the chat window with the messaging icon at the bottom of your screen. Send chats to everyone. Please feel free to ask questions during the presentation. Jess is going to moderate, and if I have to stop sharing and we need to talk about something, we can go back over. The Q&A and chat windows are located on the right side of your screen, and then there will be a survey at the end for you to fill out about the results of tonight. Okay. Lots happening when I'm sharing everything. So All right, so here's Jessica and I's contact information. We definitely wanted to give that to you guys. Jess and I both are on Twitter. We both tweet a lot the projects that we do with students, both in and out of the classroom, conferences, that kind of thing. So please feel free if you guys need something, you want to reach out to us. We're going to provide some resources about the STEM team that Texas Instruments has, but definitely you can reach out to us if you have some classroom information.
Yeah, and Stacy, your screen is not being shared right now.
Okay, thank you. Too many windows open. Thank you, Jessica.
There you go.
All right. Thanks, Jess. There's our contact information. And it will be linked at the end of the webinar with all of the documents. You'll have that as well. All right, Jess, you want to talk about why we do STEM and coding in our classrooms?
Absolutely. So both Stacy and I really felt passionate about STEM, or we've been feeling passionate about STEM for probably what, like 5 years, I think,
Yeah.
Stacy, at least. So Stacy and I met at a conference where they're introducing the TI Innovator Hub, and I was a biology teacher. Stacy's a chemistry teacher. We're like science teachers learning about STEM. Like, this isn't really for us, but then it was. We were learning about the smart irrigation system, which is one of the STEM projects that we'll share some resources about. And it just clicked for me. It was the way that I found the E in STEM, especially in the content area. Because once I started implementing some of these STEM projects, I saw such a transformative process within my students and my teaching. The students were able to really talk through problems. They were like, the communication between students like increased tremendously, where they were troubleshooting, saying, hey, what if we try this? Or let me see if this does something different. And they were able to be creative. So there wasn't a right answer in any of the activities we were doing. It was all about what they wanted to do, how they wanted to do it. And everybody had a different way of getting there. All the paths were different, but they were able to still solve a problem. But it didn't matter how they got there. And their critical thinking increased tremendously. They were able to use so many of their prior knowledge skills and grow more from just going through the problem solving process and really helping each other figure things out. And that whole figuring things out piece, that process, is really what made me want to continue with it. So it wasn't necessarily the right answer, but it's the process of how we got there, that journey that really stuck with me and my students. And I'm hoping that they, continue to find that love of figuring things out and continue to do more work in the, computer science or even STEM fields.
Yes, I think having these projects within the classroom, or in your case, an outside classroom, we foster that love of learning of students, and they're not tied into a right or wrong answer or a graded assignment. I think that's probably the best part. I noticed I've been doing more of the STEM and coding into my curricular classes, not just in my robotics class, and that has made me feel better about the future of my students, that they are those innovative problem solvers.
Yeah, and real quick, Kevin put in the chat that
Yeah.
he loves seeing his students enjoy STEM and the hands-on experience. And that I have to really point out, I never felt such joy as doing STEM projects with students. So, I could teach photosynthesis and cellular respiration all day, collect data on enzyme reactions and all that fun stuff. But when their faces light up, and it's that joy, like, I always had such joy working with these STEM projects. So yes, thank you for hitting on that, Kevin, because it is very joyful.
Absolutely. So, Jess and I, both classroom teachers, neither one of us had formal training or coming into the world as coders. So how did we get started? Well, Jess mentioned we met, my goodness, we met at a workshop where we were introduced to a few projects, went home, and then we both wanted to learn more about programming. And so just so happens TI has what's called TI codes, basically 10 minutes or give or take a few minutes where you can actually do the lessons with your students. There are units of instruction, and the units are based on skill builders. And so Jess and I really, we started just like that. We started working on our own. We would practice, learn it. We'd have these our own little TLC Zooms where we were like, hey, I learned how to do this, and I learned how to do this, and then I would go try with my students, and we just kind of go back and forth. But the way the units are set up, there are three skill builders and then an application. And the application kind of brings in the skills that are learned by the students each day. Really cool. It's entry level. The entire coding process is menu based, so you nor the students have to actually know all of the syntax. It's embedded in the software, and we're going to show you in a second. Jess and I both code in Python using the CX2s. There is a TI-84 CE Python that can code in Python. Or if you want to use the TI Basic, the TI-84 CE and the TI-Nspire CXs only do Basic, whereas the CX2s and the 84 CE Pythons do both. There is STEM integration, which we're going to show you some tonight, not just coding on the handhelds, but adding a microcontroller called the TI Innovator Hub, and then now the microbit. And then if the students are interested in a robotic type vehicle, there is what's called the TI Rover. So lots of resources Jess and I want to share with you guys too. When we got started, we kind of had to find all the resources, and then throughout the years, I think our presentations get longer and longer, Jess, because more and more resources are available. I know.
More projects that we do.
Yeah. And then when we go to a conference, we're like, okay, are we gonna do the same thing last year? No, let's be innovative and do something different. And then these webinars get longer. So first thing we want to do is kind of introduce you to Python, especially if you're brand new to coding, the difference between what's an editor and a shell page. And then we're going to look just at some general programs. This is a slide that I talked to you guys. Yeah.
Before we get started, if you don't mind putting in the chat, maybe your experience with Python. So like a 1 that you've heard it before, and a 5 like you feel fairly comfortable with the language of Python. So just to get a kind of an idea of where you all are, from 1 being the basic, like you've heard of it, but never really worked with it before, versus you paid, this is your job. You get paid to program in Python. All right, so we've got some beginners, lots of beginners, and some mediums, and a few almost experts. All right, okay, good feedback. So for those of you who put 1, don't worry, because again, as Stacy and I had said, that we were beginners too. I still feel like I'm still learning so much every time I work with students. So we'll set you up for success with this. So go ahead, sorry, Stacy, I'm sorry.
Yeah, no. So this, again, these documents will be available to you. So I'm not clicking on each one of these. We just tried to find whatever resources that TI has and kind of put them in one kind of area. So the guidebook is kind of like the user's guide to Python. It has what all the syntax means and if you're trying to understand it. The same thing with the getting started. Again, getting started. How do you write your first program if you're using different keystrokes on the CX2s? And then there's the website and then other resources, which has Innovator and Rover resources too. Not saying you have to go through them all, but sometimes you get stuck. I know one of my students the other day asked me what was the maximum value for one of the sensors we had, and I was like, I have no idea. So I went and get the guidebook, opened it up, and I was able to find the information. So we just wanted to give you resources. Other things that there are resources, obviously you're doing this webinar, so you know about webinars, but you can go back and watch some of the other on demand, the recorded webinars. There's lots on Python. There's lots on STEM projects. You might hear some voices that you recognize. There are others, and then there's some that are computer science related. And so that's kind of the new venture is that trying to get the handhelds and the Python programming into some computer science classes. So just again, another resources. I know when I first got started with TI technology, that's what I did. I went to all the on-demand webinars, and yes, I was the nerd that watched all of them, got as much information as I could before starting using it with my students. So
Yeah, and they're all searchable on the website too. So if you're looking for a specific thing, like Python, for example, you can search for that and then narrow down those webinar lists because there's tons of them.
all right, so what's the difference? And so when I open up a page in a minute, you're going to see that we're going to create our Python program in Python editor. That's where you're going to create, save, modify, that kind of thing. Cool part is that there's lots of highlighting and or color change to different syntax. So it helps with the students to identifying if they did the right type of syntax. It is all menu driven. And so there are also prompts and or I tell the students they're kind of like hints, especially with specific ones that would have ranges of information you need to add. The var key works great, especially when you're storing and saving variables, so you remember what you name them. And then there's obviously some shortcuts. Jess, you want to talk about the shell page?
Yeah, so when you run your program, a new page opens up on the calculator, which is your Python shell page. So this page will run your program. It will display what you've typed in to display. You can even do some programming in the shell page as well. And it's where you're going to actually see your program take shape. And so that's just kind of how I describe between the editor and the shell page is, the editor is for when I'm talking with students, that's where you're going to rate your program, and your shell page is where your program is going to be running.
All right, so this is kind of what it looks like. The one on the left is a Python, well, actually, it's a challenge page that kind of shows you how you can set up your information, and then shell is on the other side. All right, this is one that would have, if you wanted to do like some math equations or science equations, the one on the left is your editor page, and then the one on the right was a shell page. So they look a little different, but at the same time, you have to have the two functionalities together. All right, so let's go code.
So one of the things that I really like about the TI platform specifically for this, because I'm not sure what you all teach out there, but you might have, use Scratch or something working with the younger kids. And that's great to introduce them to coding. But when I work with high schoolers. And so the platform itself is really accessible, even for students who've never coded before or students that have advanced Python experience. It kind of meets them in the middle. So as Stacy will demonstrate, we'll see it's a menu-based system, so they don't have to memorize any syntax. As Stacy mentioned before, it will give them hints. And so what we are going to demonstrate is kind of what I would start out with my students when I'm introducing them to the handhelds or the calculators. We use them in science all the time for data collection and analysis and simulations. And if you're in a math, if you're a math teacher, you probably use calculators all the time for whatever you need to do. But this is kind of what we set up with, okay, now we're familiar with the calculator, we're familiar with the buttons. Now let's see how we can program on it.
All right, Jess, can you see the software?
I cannot.
Okay. Glad I asked before I started.
I was like, why
I feel like I'm back on Zoom. I'm sharing my screen. All right.
There you
Now
go.
you can see my software. Okay. So I went in, I did a brand new file. I opened up a new page, and this is what happened. So these are all the applications that I can do for the handheld. I'm just going to go ahead and add a Python, and I'm going to do a new Python, and I'm just going to call it hello. I don't need a different type. I'm just going to do it as is and say, okay. So if I want to use the menu, like Jess and I both mentioned that it's menu driven, so the menu is my friend. And I just want to do something easy that makes it easy for the students to actually have success on the first time, and or you if you're following along with your software or your handheld. So I want to do nothing but print something, just to say that I ran a program. So under number 4, built-ins, I have the option for what's called an I/O. An I/O is an input or an output. I can print something or I can request from a person. So I'm just going to go ahead and print. Again, I just want to run one simple program and then we're going to transition to the hub. I want to print a text statement onto my Python shell page. And so a text statement is a string variable in Python, so I have to put it in quotes. So quotes is under control and then times. So I'm just going to type in hello space world, close quotes. This allows me to finish that entire string. It's all in quotes. That's probably the number one thing kids forget is the second quotes. I'm going to get out of my parentheses just to make sure when I press enter I don't mess anything up. So it's a good opportunity when you're starting working with students in coding is ask them what do they think that line of code is going to execute or produce. And so I would hope my students would say that on the next page it should just say hello world. So I'm going to go run it.
I do this with my 15-year-olds in high school. And so this is sometimes their first line of code that they've ever written in their entire lives. And I don't have them write hello world. I have them write whatever they want. However, I work with high school students, so I give them the warning that it has to be school appropriate. And I have an LCD projector that I would project it on that I can pause, luckily, and then preview everything using the navigator system. And then project it up on the screen. And they have a lot of fun with it because they want to get laughs from other kids, as long as it's school appropriate.
And then it's theirs. It's not something that the teacher made them do. There's one right answer like Jess and I were mentioning earlier. Okay, to run this, I'm going to go to menu, and then I'm going to go to number 2 for run, and then number 1 will run it. And when I run it, I get printed on the Python shell page, hello world. And it's not like, it's not like miraculous and all big deal, but they have success with running their first program.
But you see their eyes light up like
Mm-hmm.
when they've done something new. And that's really cool to be like, hey, you wrote your first program. And they're like, yeah, I did. And it was super easy. So let's do some more.
Yes. So I want to do a program with the Innovator Hub where I'm going to pull up my document camera. I don't think we could have made this any more challenging, Jess,
Yeah.
with multiple things happening. All right, so here's my document camera with my Innovator Hub. So the hub is a microcontroller. It has ports that are out. You can plug in like a pump, a motor, an external LED. It has ports on the other side, which are in ports, and so we use those a lot for our sensors. It does have a built-in RGB LED that will turn on. There's other ports on the top for breadboard, and then there's sound output. So those are all the things that we can use just with the hub. And I want to do that. I want to create a program, or Jess and I are going to create a program where we just turn the color, the RGB color on. We turn it a different color. So Jess.
Yeah, this is a program that I will introduce my students to the hub with. So once we kind of get comfortable with using the software to program in Python, like the Hello World, when I then introduce the hub, I have them do this type of programming where they just turn on a light. And it is the most magical thing ever. You would not imagine that a single light turning on is the most exciting thing ever happening, but like what they want to do. And it starts them off like it's real simple. They just pick a color. But then they're like, well, what? I want to make a different color. I want to make my favorite color. And then I challenge them to maybe make it blink or maybe blink different colors. And so it's that, again, that low floor, high ceiling thing where there's some kids that can just make a color, but then there's kids that are off making it like adding in loops and all sorts of crazy stuff like within minutes. It's fascinating. I love it.
Absolutely. And it's theirs. Again, there's no
Absolutely.
one right or wrong answer. So I'm going to name this, I just inserted a new document or a new page, sorry, and then I made another Python program. So I'm going to call it RGB. Now, when we're using the hub or any external parts besides what we saw with the print, we have to import the modules. So the modules are built in to the menu. And so we can see we have a math module, random, plot lib, library, hub, rover, and then a whole lot more. But we're going to just import the hub module first. So from TI hub import. Now that basically, the way I teach my students, and it might be not completely correct in computer science language, but it's like having the file cabinet open and now I can get in there. If the file cabinet is closed, I can't get in there. And so now I have access to all those menus.
Yeah, I use the book analogy. So, like, Python is like this huge library of commands and whatnot. And we're really only using a book out of it. So, we're pulling the hub book out and using whatever commands and prompts we need from that particular book.
Yeah,
So,
that's a good one
again,
too.
I don't have the programming background either. So, who knows if that's correct?
Okay, so um, we want to turn the color on. So I'm going to go to menu. We said everything is menu driven. So I'm going to go to menu, hub. It's built in. I have no external things plugged in. So I'm going to go to the built-in menu. And then number one for color output. And then Jess said she was mentioning like blink. Tonight we're just going to turn our red, green, blue on. So Jess, what color you want?
Let's do blue.
Jess wants
Or
blue. So
aquamarine. Let's do aquamarine.
the RGB
Yeah.
values love.
Let's play around. Let's see if we can make it.
It's a mixture of blue and green, right? So
Sure.
that's another thing is the kids they'll do the first one, that you tell them to do, and then all of a sudden they're like, grab the Miss, can I have my phone out? And they start Google searching what are some RGB values, and they get so excited. Like Jess said, they want their favorite color.
Yeah.
So the values are 0 to 255. So I'm going to go 0 for red. I'm going to put 115. I don't know, Jessica. I don't know what they are.
Let's find out.
But yeah,
That's the
but
best thing about this.
you have to have it for all three values. So I need
Well,
to
and the great
share.
thing about this is like students will ask me like, well, what color is this? I'm like, I don't know. Let's find out. And that's how like a lot of my responses are when working with kids is like, what's going to happen? I don't know. Let's find out. All right, let's find out. What's
Yep.
going to happen? So many screens.
I know I'm trying to get it so that it's not all the way closed and to the side a little bit because I got to run it.
So you're on 1.1 rather than 1.3. There you go.
I'm just gonna do like this. So we have it's bluish. It's kind of
It's
hard to see
bluish
because the
green.
light's in here. It's pretty good. I could probably add some extra green to it just to get you aquamarine.
All right.
Um, so the question I want to ask the students is why didn't it go off?
Ooh, that's a
So
good
Jess, why
question.
didn't it
Let's
go
ask the
off?
chat. Why did the light not go off?
Why is it still on? I told it to run and it ran and it made the light come on. Why did the light not go off?
Why is it still on? Yeah, Josh. Yeah, we did not tell it to stop.
Right, we never said to not turn the light on. And that's part of coding and working with students is that they have to understand that every single, every single line of code has meaning to the actual program. And so I would then need to tell it to turn the color off or to turn a different color. Very cool, very cool. All right, Jess. Where we got? All right, so we ran our first program. We added, yep, we played with the hub. So the file that you see here would be if we wanted it in a loop, like Jess mentioned, that her students do sometimes. Jess, you want to go through it? I'm trying to plug in the microbit now. Okay.
Yeah, no worries. So with the menu-based system, as Stacy just demonstrated, is kind of like where I would start with my students. And then oftentimes, once they get comfortable, they'll just kind of go through the menu and find things, like as Stacy showed in that first menu, that there was a blink function as well, and or blink command. And so some of them will just play with it. And that's kind of really what we want our students to do, to feel confident and comfortable just playing and figuring things out and making mistakes and learning from them. And so this program, I should say, this while get key doesn't equal that exclamation point equals means does not. It hit escape. So basically this is a while loop. So it's going to be running until we hit escape. And in this case, this range is going to go 5 times. We're going to turn the color RGB 25500. What color will that be? Any guesses in the chat? Of RGB 25500, red, yes. And then that sleep for 0.5, what does that mean? If we went to sleep for 0.5, yeah, so it's going to turn off for half a second. And then what color is going to come up next? Green. And then again, sleep for 0.5 seconds. And then what color will be next? This is a hard one. It's not obvious. Yellow. Yeah. So what did we just code here? What did we just make this program to do? What did it show? What? Yeah, we've got this stoplight. So we've made a stoplight with our Innovator Hub. And so that's kind of the next progression once we have the RGB figured out. Now we put them to the test. Okay, so let's solve a problem. Let's create a traffic light and then maybe add some sounds. So if someone who might be blind that comes up here, that, you know, they would be able to know when to stop and when to walk. And so you can look at, you know, making certain scenarios around your models to apply it to real world problems.
Yeah, that's that real world connection that we can take something that we currently see either in society or we can try to make it better. So I love that aspect of it. And the kids always have a blast with the sounds part too. All right, so microbit is next up. We're going to look at microbit for a second. So microbit is a newer adventure for TI. They've realized that a lot of schools had microbits. And so what we're going to show you tonight is just basics of microbit. But basically, microbit is another type of microcontroller. And this microcontroller, I'm coming. I'm loading all the windows. It looks like this. So I apologize. My hand's in the way and everything. I have a short cable tonight. So it has a little Texas. And then I love the fact that this was my thought process, but it might not be, that the brighter of the LEDs is kind of like where Dallas is. I don't know if you can see that it's Texas. But the microbit has this LED. No, it does not connect to the hub. It actually connects straight to the handheld, or right now I have mine on my teacher software. So it's separate from the hub. It's just another different microcontroller. So we have this LED display that right now is just displaying Texas. We have 2 different buttons that we can use to press. This actually is a touch as well. And then there's multiple sensors. There's an accelerometer, there's a speaker, there's a microphone, there's a temperature sensor, there's a light level sensor. And which is Jess and I's new adventures we're trying to get into, is that you can connect using some alligator clips or an additional they call it a bit board, and plug this microbit in and then add the same sensors we use in some of our other STEM projects. So really, really exciting stuff that, I don't know, I think it's fun.
Yeah, Shanta asked where if you can purchase this, and yes, you can purchase this. TI doesn't sell anything directly. You could probably just Google microbit to find distributors. I know the last time I looked for them, they were kind of hard to find. They're all back ordered because they've been pretty popular. So I know Stacy wrote a grant and got like a bunch for her classroom.
Yep. I got
So
an email today. Let me see. That one company, I'll pull it up while we talk in a minute, but it talked about the fact that there were microbits that were available. The issue was the chip, with all the shortage of chips and stuff in some of the cars and everything. Yeah, so Shanta, if you want, I put my contact information. Jess, if you want to add it to the chat, and she can grab that and we can talk afterwards.
sure.
So I'm just going to call this MB for microbit, just to kind of show a quick code real quick. So I mentioned, like with Hub, we had to import a module. It's the same thing for microbit. So I'm going to import that module, menu. This is more modules. Now this is not part of the actual software right now. So if you have the software, you have to actually go to the TI website and download the update for the software, and then a file you have to put on microbits. So just kind of know that if there's some issues that you have with microbits, you can either reach out to Jess or myself or members of the STEM team.
But there are 10 minutes of code for microbit now, so that will help
Correct.
kind of introduce you to it
Correct.
for sure.
Was it when we started, Jess?
Yes.
All right, so I have the microbit import, and then I just want to show you a few things with it, and then Jess and I have a whole bunch of other resources to share with you. So under microbit, so these are all the different things microbit can do. Commands, like we saw the while get key earlier. One is that the sleep is in milliseconds, so the kids have to get used to that. That LED display that I mentioned, I can show an image or a text, or I can scroll, which is my favorite part. This set pixel, if I had to guess, that's how Texas Instruments got the Texas symbol with the bright star in the
For Dallas.
for Dallas. Thank you. So I'm going to display or show something, and so I have to go back to that same area. But I'm going to go now to images. And so kids love this. They will spend all day changing the different images. So I'm just going to go and do a heart. All right, so it says display dot show and it's an image. So I'm going to Control R, I'm going to run it. And you can't see it because I have to share that. So let me share my document camera. And so you can see there's a little heart there, right? So they get really excited. You can change the heart, so I can display, show a big one, and then sleep, and then show a small one, and then go back to a big one. So it looks like it's beating.
Yeah, beating heart.
It's like a beating heart. It's so cute. I could do a if statement, like if A is pressed, show a different symbol or text. If B is pressed, so show something different. Just really introductory, but fun. So much fun for the kids. There is a radio function of microbit that my kids play Duck Duck Goose. So you can connect the the microbits to each other through different channels using the radio, and then they take it and basically they're using the accelerometer of it to toss the duck, and they play Duck Duck Goose stops. It's so much fun to see who has the duck with the radio. Anyway, they really love microbit. I'm like I mentioned, I'm trying to get into more with the sensors. Just still brand new for me. I think it's still brand new for a lot of people, but it gives me, that joy and excitement to get to share that with students.
Yeah, that joy. I mean, I can imagine the giggles in your classroom with playing with microbits with Duck Duck Goose with high schoolers. They probably
What was that
eating
game?
up.
It was Flappy Duck. Was that a
Oh,
game?
yes.
Yeah.
That's what it
So
was.
one of my students created he wrote a program. I didn't teach him this. He wrote a program in Python connecting to the microbit and the Flappy Duck. So if he pressed A, the duck would go, but then he would have to jump over like different things and stuff. It was crazy to see him do that. He just came in during the skinny period and programmed it. That's the beauty, right? When they come in after class, they're like, Miss, can I work on this project? Whatever.
Well, and that's the thing, like when working on STEM projects, I feel like the kids never want to leave the room because they just want to like tinker with it and make it right. What they want to, like, they have a vision in their head and they want to see it through. And it's like, why doesn't that work with osmosis? And,
Stoichiometry. What you talking
right.
about? Well, I'm here, at this conference, and I had to assign my students some work, and I can't very well let them code while I'm not there. So they were like, "Man, we have to do a research project. Can we just play with microbits?" I'm like, "No." So, all right,
Yeah.
some different projects and resources. So Jess and I first, like she said, we met at a conference, and then kind of got started with this. So we want to show you a website that has some resources. So Jess, I've been talking. I feel like I'm hogging the whole webinar. If you want to walk through
No.
some of the resources.
Yeah, sure. So the TI-Stemprojects.com, and I'll try to type it out while I talk in the chat. Hopefully I'm not spelling it incorrectly. TI-Stemprojects.com. All right, hopefully that works. So this is a very valuable resource, and I can't say enough about the STEM team. So the STEM team would be your contact with any of these projects, and we'll kind of preview a few of them later on, but they have teacher documents, they have student documents, they have videos. You can borrow all of them for free, and then you can request equipment, the request to borrow equipment. So if you're like, hey, I want to try this smart irrigation system, or I want to try this mood ring, or I want to try something with the rover, you can request to borrow the equipment. They'll ship it to you through FedEx in a Pelican case. They'll have a little FedEx tag in there with you or with the materials, and you just send it back after a certain amount of weeks. They can also talk to you. So if you need like more help, so you can contact the STEM team and they'll set up, a Zoom call or whatever to kind of work through it with you before you work with your students. And it's, again, they really want you to succeed with this. We want you to succeed with this because we've seen the value of it in our own classrooms and our content classrooms as well. So if you're a STEM teacher and you have some science or math teachers and you do something fun and you see some connection with standards, be like, hey, this is something you can do too. But let's show some of the set examples. So these projects right now are with the Innovator Hub. There aren't any STEM projects with the microbit yet, but I am sure they will be coming. And they're set up for Python, as well as the TI Basic, which you can use with your TI-84 or TI-Nspire. So there's a variety of things. I like the mood ring to start with because it's real simple. It just uses one temperature sensor. The pet car alarm, Stacy and I have adapted to make it a little bit simpler, and we have a conference session called dog mode. Like in Tesla, they have something called dog mode, so it's kind of the same thing where you're trying to see if you leave a dog in a car, how could you alert the owner or people around to save it so it doesn't, overheat and die. Then we mentioned the smart irrigation system, which is a great program that really inspired me as a biology teacher that I could do STEM in my classroom because we are building a smart irrigation system. So based on certain inputs, so temperature, humidity, light level, moisture, that would determine when the pump gets turned on. And we were just planning a native plant garden. And I was like, oh, we could build a model of how to water our garden sustainably. And it made so much sense. And I was like, mind blown. The Heart Project I've also done with my AP Bio students after the AP exam. So Stacey, you mentioned that your kids didn't code without you. So I spent the week before the AP reading going over the first part of the heart project, and then I modeled, or I actually created an extension to the heart project where they had to investigate their a type of arrhythmia, and then they had to go back and change their code to show how that would be represented in the heartbeat. And so that was like a research project too, but they still got to code. And again, so post AP exam, post seniors, it was fantastic. You can do music, you can play with the vernier sensors. If you have vernier sensors, they work with the hub. There's something called the array where you can make things turn colors. It has 16 LEDs. The rover is always fun in the math classroom and the science classroom too. So it's a little robotic car that you can program to move. So there's lots of things in a science classroom. They have a lot of Mars-based challenges like the Mars rover. So there's the possibilities are endless. And both Stacy and I kind of got started with these projects. They helped us figure out what we wanted to do with our students. And then we've started since then kind of coming up with our own thing. So they gave us the confidence and the skills to be like, you know what? This thing that I've always done before in my classroom, why don't I use this technology to kind of bring it out, bring it alive so that my students really can feel engaged with it? And so Stacey had some projects that she's going to show you too.
Yep. So I always start with 10 minutes of code. And we did the traffic light like you saw earlier, making it go through the 3 different colors. That's their first success. Like Jess said, low floor, high ceiling, really easy for them to do. We did some rover projects where rover draws a shape, either a flat shape. Some of the students tried to do a 3-dimensional shape with drawing it that way. And then I have the students switch papers, and then the other students have to try to draw or mimic that other shape, but either scale it up or down without knowing the lines of code. So pulling in that math link to those projects. There's a breadboard port where you can have other accessories plugged in. This is a breadboard, and my students actually made their own speaker with magnetic wire, nail, and a styrofoam cup. If you see the gloves, this was right when we got back after COVID, and they had to wear gloves in order to be able to do any projects because I can't very well sanitize every single wire and LED. So the kids really love those path to STEM. The path to STEM were things like where you build your own thermometer through a thermistor, you build your own conductivity sensor with some magnetic wires, those kinds of things. But you're using the breadboard port and you're understanding about circuitry and resistors and transistors, and lots of fun. Way more than I ever thought I'd ever be doing as a chemistry teacher. They built an automatic dispenser. So the hub has a brightness sensor, and then based on brightness values, it dispensed beans. They really love that one. That one's probably one of their favorites in the beginning of the year. I just mentioned about the link with the veneer sensor. So it's called a sensor link. This is it right here. It plugs into the hub. And then right here we have a veneer pH sensor. And so what the students had to do was to use either the pH sensor, the temperature sensor, or the gas pressure sensor to design some kind of, if the value is this, then go do something. And this student decided to create an automated pH changer for a swimming pool. This is what it's showing here. So this cup is hooked up to a little servo motor, and then based on the pH value, it turned the motor to allow something to dump. This is that temperature sensor I was talking about, and so we created it. Not only did they create the sensor, they had to calibrate the sensor. So we used a easy temp vernier sensor plugged into the calculator to collect temperature data. Then of multiple liquids, they graphed it, and then they had to take this temperature sensor that they created, same 3 liquids, and come up with the comparison of the mathematical model to what they got versus the actual temperature data. So that was a really fun project. Oh, this is microbits. It was a warning system. So like if they were in like a chemical lab or whatever, and the temperature got too hot, it scrolled through hot. It's plugged in the hub, and then the hub had the little light display as well. These guys also used an external light, or an external LED to turn on if the temperature got to be too high. And they had a pump up here at the top that pumped cold water in to cool it off. Again, all I told them was that they had to design a warning system and they had to use microbit and they could do any of the other things we used all year. And so that's how creative they get. It was not me. I did not teach them all of this as one project, which is the coolest part. Oh, Jess, here you go. Your turn.
Yeah. And we had some questions about where can teachers share lesson plan ideas. So in the chat, I put there is a new Facebook community called TI Teacher Community that you can search for if you're on Facebook and join, where people will share ideas, or if you have questions, I'm sure you can ask. I also put a link to our TI Bulletin blog site where a lot of teachers have shared their own projects, Stacy and I included in that, but there's also a lot of others, including some math ones as well. And so Stacy and I are not math teachers, but we are more STEM focused, but there's probably a lot of math components that you could infuse within a lot of this stuff. This one, smart irrigation, so you could probably look at flow rate. And so this is the one I mentioned before where there's certain inputs where we're looking at temperature, humidity, moisture level, and light level. And based on that intake, the students will write a program and figure out what parameters will allow for the pump to turn on in order to water without wasting. So they have to understand a little bit about plants and the environment, the biome that they're watering in. So is it, dry, is it humid, and there's some components to that. And there's, they come up with some creative stuff. So this is kind of a sample where there's a moisture sensor that's being put into the plant. Their temperature and humidity are on the outside of it, and the pump is in that container in the back. So what happens here is it's set to program to when the light level is down. So when it's dark out and the moisture level is low, and that it's above a certain temperature, that the pump will turn on. It's kind of hard to see in this video because the light comes down, but if you look at the very top center, you can see the water coming out of the tube. And once that moisture sensor gets triggered, when that threshold gets reached, then the pump turns off. And so it's a great way to introduce students to input and control, or feedback and control as well. And so this is showing the heart project. So this is one of my AP students setting up their heart using Play-Doh as it's conducting the electricity throughout the heart, and they're making a AED. So they're shocking the heart back to life. Because the program has it goes through a certain number of loops, and then it flatlines, and then they use some input of electrical signals to jump it back to life, and they just love it. It's a lot of fun. This is a project that I created kind of based off the experiences that I've had with some of the other STEM projects. And so this is based off of something kind of near me. In Maryland, there is something called Mr. Trash Wheel in Baltimore City. There's actually 4 trash wheels. There's a Mr. Trash Wheel, a Professor Trash Wheel, a Captain Trash Wheel, and Gwenda, the Good Wheel of the West. And they're all these innovative trash interceptors that take in trash. And so I was like, you know what? I bet my students could make a model of this. And so they did. And so we focused our lesson around human impact of single-use plastics. So we collected single-use plastics and we built our models out of it. And we worked in groups, and there was a software engineer, there was a mechanical engineer, there was a project manager, and then there was a marketing and design person that made their projects super cute, like our little reindeer on the bottom right. So because that's the point of like the whole trash wheel thing, is that it's not just doesn't it just not just only takes trash out of the water, but it also informs people. It has a social media site, so they had to create a PSA too. It also has these googly eyes on it, which is weird and cute at the same time. And so seeing how all of this kind of gets put together, and it gives them just an experience. And that's really, as a content teacher, I don't expect my students to go out into the world and become computer programmers necessarily, but I want them to be exposed to it, to dismantle some of those misconceptions that they may have, to say, hey, this wasn't as hard as I thought it could be. Maybe I'm pretty good at that, or maybe I really enjoyed it. And that's the point where I was thinking of, like, content teachers really need to do this more, just to expose their students to it. So Stacy.
Yeah, I'm here. I'm sorry. I had to go get the links
Like,
and I can't share at the same time. All right. So Jess and I showed you guys how to borrow supplies. So that's definitely what I would get started with. You're going to go to the TI STEM Projects website to borrow the supplies. Here's our contact information if you want to jot that down again. Like I said, I'm going to put in the chat in a few minutes the link to the certificate of attendance, as well as your documents. You'll also get a email in a couple of days with a link to the recording, and all the links to all the documents. Just if you don't mind, if you have any questions before we get off, go ahead and put them in the chat. Just that so Jess and I can answer any of your questions. A brief survey will also pop up. That survey will help us to prepare future webinars. So please, please, please give us your feedback, or give TI your feedback. They do listen. We've had a lot of requests for more STEM projects like this. So if that's something you're interested in, by all means, please reach out. Or if you have more coding that you would like, works as well. And then I did mention that there was going to be a winner for a handheld or TI technology, and the winner is Kevin Bradley. Congratulations, Kevin. Someone from TI will be contacting you after this webinar and get your information from you about how to get that to you. If you were on Twitter or any social media, please share what you learned today. I think sharing is caring when it comes to professional learning, as well as whatever you learned, or you want to continue the conversation. Just mentioned the TI Facebook, that they want to share that information out there. Great for that. But then you can always use at TI Calculators or hashtag T3Learns, which is this part. Jess and I both absolutely love Twitter, and can't get enough of it. So thank you guys for joining us. Thanks, Jess. Thank you all for being patient with the screen sharing. Hosting and leading a webinar and sharing everything was tough, so I appreciate your patience. Thank you all for coming tonight. Be on the lookout for the link to the recording as well as all the documents. And we hope to see you back soon. And I hope you guys all have a good night.
Thanks. Good night.